Welcome to the WION podcast. We've got something pretty big from our own cosmic backyard to talk about today.
That's right. The sun's been active. We've seen, a really significant solar flare erupt recently.
Oh, flare. Okay, tell us more. What exactly happened?
So around 4:25 a.m. Eastern Time, there was this massive burst of energy from the sun. It came from an active sunspot region, designated AR4007.
And this was a big one.
Oh, yeah. It was classified as an X-class flare,
Yeah.
specifically an X2.7.
X-class. I know that's the top category, right?
It is, yeah. A, B, C, M, and then X is the most powerful. Now, X2.7 is, on the lower end of the X scale, but still, it's a major event, not something you see every day.
And I heard it caused some immediate problems.
It did. Because of where Earth was rotated, the parts facing the sun at that moment, Europe, Asia, the Middle East, they experienced strong radio blackouts.
Blackouts. How does a flare cause that?
Well, the flare emits this intense pulse of X-rays and extreme ultraviolet radiation. It travels at the speed of light and hits Earth's upper atmosphere, the ionosphere.
And that messes with radio waves.
Exactly, especially high-frequency radio signals. So communications were disrupted pretty much instantly in those sunlit regions.
Wow. You mentioned the scale. How big was this thing visually on the sun?
It was huge. Estimates put the length of the eruption at nearly 1 million kilometers across the sun's surface. Some descriptions compared it to, like, a giant bird's wing unfolding.
1 million kilometers.
Uh-huh.
Hard to even picture. So radiation caused the blackouts? What about these CMEs, coronal mass ejections? Was there one of those?
Right, that's the next big question. CMEs are different. They're these enormous clouds of solar plasma and magnetic fields that get thrown out from the sun. They travel slower than the radiation.
And those are the ones that can cause the northern lights and maybe power grid issues?
Precisely. If a CME hits Earth's magnetic field, it can trigger geomagnetic storms. That leads to the beautiful auroras, but potentially also disruptions to satellites, communications, and power grids.
So did this X2.7 flare have a CME with it?
Initially, it wasn't entirely clear. The sunspot, AR4087, was actually positioned near the edge, the limb of the sun when the flare happened.
Okay, so maybe we dodged a bullet if any CME wasn't aimed directly at us.
That was the initial thought. But the situation's developing. This sunspot region is rotating.
Rotating towards us.
Exactly. It's turning to face Earth more directly. And the key thing is it's still really active.
Still firing off flares?
Yes. After the big X2.71, it produced several more M-class flares, still significant events. There was an M5.3 and even an M7.7 flare reported.
Okay, so this active region is turning towards Earth and still popping off. That sounds potentially concerning.
It means we need to keep a close eye on it. If AR407 continues this activity while it's facing Earth, any CMEs it produces could be Earth-directed.
Which could lead to those geomagnetic storms you mentioned.
Yes. We could be looking at strong geomagnetic storms, potentially impacting communications and other technology. It's a real possibility.
But there's always the upside with these things, isn't there? The prettier side effect.
Absolutely. The silver lining is always the aurora. Stronger geomagnetic storms often mean more intense and widespread auroras. We might see the northern and southern lights much further from the poles than usual.
So a bit of a cosmic light show could be heading our way, alongside the potential for some disruptions. Definitely intriguing stuff from the sun.
It really is. A good reminder of how connected we are to our star and its behavior.
Well, thanks for breaking that down for us. Fascinating and maybe a little bit unnerving.
Always interesting to watch the sun.
Indeed. And thanks to all of you for joining us on the WION podcast. Make sure you stay tuned for more deep dives into intriguing stories like this one.